All right, welcome back, everybody. We're still on Chapter 6, and this is called 6.4, Solving Special Systems of Equations. It's kind of reviewing what we've learned. So we've learned three methods: graphing, substitution, and elimination. I didn't make you take notes, but look at this and use this as a reference. When should we use graphing? Well, we should use graphing if both equations are equal to y, because then it's easy to graph, and if we're not worried about the solution being exact, because if these two do not touch in an exact spot, then you might have to guess. All right, and if you have graph paper available too. When is substitution a good method? Well, if the variable in either equation has a coefficient of 1. So if the variable is by itself, like x, or if it's here and you could get it by itself easily. And especially if both equations are solved for the same variable. So that would be like right here. Okay? So that you could just set these equal to each other and then you could solve it. So that's a good time. Good time to use substitution. When would we use elimination? Elimination is used when both equations have the same variable with the same and opposite coefficients. So for example, this one's not set up, but if this was negative 2y and this was negative, then we could do elimination. Here we could make it by multiplying this and making it 6, negative 6, and this would be negative 4, and this would be negative 30. So we could do it on that one. That one's not as easy, but we could definitely do it. So I just wanted everyone to be aware of when to use these methods and which one would be the easiest to use in what situation. I also wanted to talk about the different kind of graphs we're going to encounter. You've done a lot of graphs like this, and this, when this happens, we have only one solution. Okay, and when does it happen? It's when we have different slopes. If the slopes are different, you're going to get those lines will touch somewhere. Infinite many solutions is when you graph a line. So you graph one line, all right? So maybe you graph it in red, but then you graph the blue line, and that line is right on top of the red line. It's the same line, and that's when it's the same slope and the same y-intercept. Here's some examples. So maybe this red line was x or y equals x minus 2. Start at negative 2, go up 1 over 1. And then the blue line is the exact same. You start at negative 2, go up 1 over 1. So that when that happens, you have infinite solutions because really any points on either equation will work because it's the same equation. I did go back to this one. I mean, here's an example. I don't know if this is the exact equation, but you have the blue equation going this way and the red equation going this way, and they do touch. Notice that they have different slopes. Now let's look at parallel lines. So we have parallel lines, and when you get parallel lines, there is no solution. And that's what we write. Notice they both have a slope of 1, so they have the same slope, but they start in different spots. This one starts at negative 2 and this one starts at positive 2. So that would be parallel lines, no solution. So it's important to remember these because we will ask you if how many solutions you have. So if you see something with different slopes, they'll touch once. If you see something with the same slope and the same y-intercept, well then that's the same line. You say infinite. And if they're same slope, different starting spots, you say no solution. Okay, we're asked to give the number of solutions, so you can look at the notes from the other page, and then solve it. So first, I need to find the slope. The slope is 1 here, but this has to get solved for y, so we're going to have to move this x over here. So look at what I did. I took the minus x and I added it to both sides, so I got x plus 3. So I wrote that right here for my red equation. Y equals x plus 3. And my black equation is up here. Here's my black equation. And that one is already good to go. X minus 4. So let's compare the slopes. The slope here is 1 and the slope here is 1. So I can look at my chart and it tells me same slope could mean no solution. Well, this is starting in a different spot. So this will have 0 solutions. And the answer will be no solution. But let's find out what happens when we solve it. I'm going to use substitution because I have both of the y's by itself, so it'll look like this. X minus 4 equals x plus 3. So, how do I move a minus 4 to the other side? I add 4 to the other side, and when I do that, I get, add 4 to the other side, I get 7. So now I have x plus 7 equals x. So how do I get rid of this x? I have to minus it from the other side. Now watch what happens. When I minus the x, what's x minus x? That equals 0. And now I have 0 equals 7. Is that true or false? Well, that's false. So if your final equation is false, so 0 equals 7, that's false, then you say no solution. That way you can do it. So let's say you do this problem and you don't notice that the slopes are the same. As you solve it, you might go, oh my gosh, the x is gone. Oh, okay, it's no solution because these are not equal. So we need to give the number of solutions and then it says solve. So let's get y by itself on this one. I'm going to be unconventional here, and I'm going to take this negative y or minus y, and I'm going to add it over here. And it'll be nice because when I do that, watch what I get. I get 3x plus 2, because this cancels, equals positive y. So I'm ready. Here's my slope. Here's my y-intercept. Perfect. So now I'm going to take this and write it down here. And I'm going to write 3x plus 2, so 3x plus 2, and it says equals y. Well, whoa. Look at this. It's the exact same equation. So if you have the exact same equation, same slope, same y-intercept, that is a red line on top of a blue line, or vice versa. It's the same. So we say infinite, that means infinite solutions. That is our answer. So let's see what happens if we solve it algebraically. If I line these two up and I put the blue equation on the left and the black equation on the right, I get 3x plus 2 equals 3x plus 2. Well, I'm going to minus 2 from both sides, and then I get 3x equals 3x plus 0. So that's a 0. So now I need to minus 3x to move it over to the other one. And when I do that, this becomes 0, and this becomes 0 here. So, does 0 equal 0? I would say true. It does. So then I say infinite solutions. And this symbol right here means infinity. So that's my answer. Here we go. Let's solve this and give the number of solutions. So let's get y by itself. So how do I move this 2x over here? What I'll do is I'm going to minus 2x to move it. If I rewrite this, it looks like this. Y equals negative 2x, because I moved it, it's negative, plus 1. So that is this equation here. So now I'll do red. My top equation says y equals negative 2x plus 5. So if you spot that the slopes are the same, and the y-intercepts are different, you can say no solution. All right? That's okay. But if you're not sure, solve it. Okay? So write on this side, write negative 2x plus 1, we'll do substitution, equals negative 2x plus 5. Then add 2x to both sides, and you end up with 0. So 0 plus 1 is 1. 1 equals 5. Okay, because 0 plus 5. So, does 1 equal 5? No. So if it's no, it does not. That's no solution. All right, we have a word question. Mandy is skating at 5 miles per hour. Nikki is skating at 6 miles per hour and started 1 mile behind Mandy. If their rates stay the same, will Mandy catch up with Nikki? First of all, we need to change something. I think change this to will Nikki catch up with Mandy, okay? Because Nikki is a mile behind Mandy. Now let's set up some equations. Mandy will do that in red. Mandy is skating at 5 miles per hour. So 5x. That stands for Mandy. Any Barry Manilow fans out there? If you are, you're probably singing the song Mandy right now. Otherwise, you have no idea what I'm talking about. Nikki is skating at 6 miles per hour. We'll have that be in blue. Nikki, 6 miles per hour, so she's 6x, but a mile behind Mandy. So we're going to minus 1 from her because she's a mile behind, and that represents Nikki. Prince fans, that would be a different song. So, well, it says, will Nikki catch up with Mandy? And let's see. First of all, look at their slopes. Are they different? Yes. So that means they will touch. This red line will touch, or this blue line will touch the red line. If you were to graph it, look, it would touch right here. The red line starts at 0, Mandy, but Nikki, she starts an hour behind. But look she does catch because she's steeper. It's a steeper pace, faster pace. It will touch right there. So we could solve this and find where they touch. And I did it really quick, but I got x is 1. So in 1 hour, Nikki will catch Mandy. So this would definitely be a yes. Okay, let's do practice problems. So here are our practice problems. Find out, set it up and find the slope, and then determine how many solutions are, and then solve it. Same for both of these. So not a lot of practice problems, so take care and bring any questions you have to class next time we meet.